Hello, everybody, and welcome to Pocket Coach. Today's experiment is a little more technical than we've been doing lately. This is about architecture. We're going to do 3 videos on architecture. The first one is what is the difference between architecture and design? The second one is how do you work on architecture and still be agile without having big architecture, big requirements up front? And then the third one is going to be on reuse and how do you create reuse libraries. So let's start with what is the difference between architecture and design? You guys can read the little experiment statement here that I have on every video. I'm going to stop reading through those. You guys can just pause and look at them. But here's the important thing. We need our architects to spend time on architecture. Oops, forgot to stop the clock. Let's see. We need our architects to be focused on architecture, not on design work. And what happens is our architects are scarce resources. They end up doing a lot of they don't have time. So we need to distinguish what is architecture, what is design. Have your architects stick to architecture and have your developers do design and code together, right? So that's the idea behind this video. Let's take a look at the magic sauce here. So the header slide here is architecture versus design versus agile. Again, this is how do you do the agile part. This one deck is going to cover all 3 experiments. Okay, so we're just going to hit one portion of the deck now. That's a third. Okay, so let's get into the agenda. This is everything that's covered in this deck. It starts with the definition of architecture. And I love asking my architects to define this because they struggle. And what is the difference? And they're like, oh, it's upfront design. It's high-level design. They keep using the word design to describe architecture. That's how you know there's a problem. So here is my definition of architecture. It's really basically 2 things: maximizing reuse and ensuring quality. Now, yes, exploring new technologies. Absolutely. I agree that's part of it, but that's the fun part, and it's a lot less common. The part that happens the most is these 2 things: maximizing reuse and ensuring quality. I can't teach you much about exploring new technologies. Keep doing that. But I can teach you about maximizing reuse and ensuring quality. So for maximizing reuse, we're going to talk about patterns in a separate video. Actually, I think we'll do that one here. And standards, you should already know, but standards are a pattern, right? That we're all supposed to adhere to. So it is another form of pattern. And then separation of concern, that's the heart of our discussion today. Design versus architecture. What is the difference? And then ensuring quality. This is entirely the architect's job to ensure that every system has good usability, reliability, performance, and supportability. These are the ILITs. I was taught this acronym a long, long time ago, ERPs, by Dean Leffingwell, who later went on to invent SAFe, right? But he had ERPs a long time before that. So I don't know if he invented that or reused it, but that's who I learned it from. So the architect's job is to maximize reuse. The architect's job is to ensure quality. It is not to design systems. It's not to code systems. It's to do these 2 things. So let's get into it a little deeper. So architecture versus design, separation of concerns. This is the beginning. Okay. So architecture is not high-level design. The fact that you have to use the word design at all in that sentence means you're on the wrong track, right? It is domain free. What does that mean? It means that when I look at your architectural assets, I can't tell what systems they describe. Like, is it a Mars rover or is it a Carnival merry-go-round? I have no idea from the architecture. That's domain free. They're focused on reuse and quality, which we just saw from the previous slide. And they also ensure that we achieve those non-functional requirements. We have a separate video on non-functional requirements. The architect is the one who makes sure that we have them, that they're good, and that we satisfy them. Right. So any architect should be watching those non-functional requirements videos more than like an analyst would. They also help us understand design constraints and interface requirements. All this kind of goes under architecture. Okay. Design, on the other hand, they focus on the functional requirements, domain specific. So what does that mean? By looking at the design, I can tell that it's a Mars rover or a Ferris wheel or a merry-go-round. I can't from the architecture, but I can from the design. So it's domain specific. And then it tells us what the system is going to do. That's why it's domain specific. And it's constrained by the architecture. So as I write my design, there needs to be architectural patterns that tell me if I'm on the right track or on the wrong track. And I can break that pattern. I can break the architecture patterns, but I must collaborate with the architects to do so. And the architecture might grow and change because of that. So we're not telling designers no. We're telling them, here's the agreed upon set by which you don't have to talk to us, right? Do this, you're good. And that's great because that means I have more time for architecture work. But when you want to break that architecture, yeah, that's reasonable. You might know more than an architect for a specific instance, but you got to negotiate it with the architects so the architecture grows and everybody's aware. Okay. So that brings us to these 2 diagrams that really talk about the separation of concerns. And this is what I'm really excited to share with you guys. So I'm going to start with slide 7 here, A, B, C, D. So this is a great little 4 blocker that describes 4 different types of thinking when it comes to architecture versus design. So first off, architecture versus design, the left side here, A and C, is architecture. The right side over here is B and D. So now we're going to be very specific about the difference. But notice A and B have something in common and C and D have something in common too. That's hence the 4x4. So let's take a look. Architecture is going to be non-functional requirement driven versus design that's functionally requirement driven. So that's kind of interesting, right? So take a look. If we look at the top 2 things, A and B, they're both, one's architecture, one's design, but they're both platform independent models, technology free or ideal architecture, ideal design. What does that mean? It means that I cannot determine the technologies. I'm going to reset that clock for my second 5. We can't tell what technologies you're using. So if I were to look at assets that cover A, I would not know the technology. If I looked at the assets that covered B, I would not know the technology. This is huge. Oh, I didn't hit start. This is huge because I got many companies who are like, oh, we can't start design until we know the technologies. And I'm like, that's not true. You can do A and B. There's 2 major design, architecture and design things that you can do without knowing any of the technologies that you're planning on using. And it's like, what? How is that possible? Okay. Now down here, C and D, instead of PIM, it's PSM. Instead of platform independent model, it's a platform specific model. What does platform independent mean? I don't know what platform. I don't know what technology. Platform specific means I do know what technology. So once we get into once we know the technologies, we can move into C and D. And so this is a massive accelerator in terms of the work, because you can do A and B before you know your technologies. While you're changing trade-offs and all that, you can still do A and B. Okay, so they call this technology specific architecture, technology specific design, or real architecture, real design. I like using ideal and real. Ideal architecture, ideal design, real architecture, and real design. Ideal is tech free design, and real is tech specific. Okay, so there's some dependencies on here, but you get kind of the gist here. Architecture, they call this one architectural analysis. This one's architectural design. This one is platform independent design and platform specific design. Some vocabulary there. Okay, so now let's go back to slide 6, where we can kind of start to really see how this works. So up top here, we have what you might call a requirement model. Think of it as the stuff we got to do. And that should be 2 kinds of things in there. There should be functional requirements telling us a student should be able to register for courses. That's functional. I can tell it's a student registration system. It's domain specific. And then non-functional, that's the stuff that's generic, the usability required, right? If I said the system must be easy to use and must meet performance requirements, I don't know what domain you're talking about. Every system could have those. That's the architecture side. That is the technology, the domain free stuff. So if you go back to 7, then A and C are both going to be domain free. I cannot tell the domain when I look at architectural assets. I can only tell a domain when I look at B and D, when I look at design assets. And now you're starting to get the difference. Architecture is always domain free. Design is always domain specific. Okay. All right, let's go back. So what that means then, functional requirements are what the system does. Student can register for courses. That's going to drive design. Non-functional requirements are performance, reliability, usability. That's going to drive architecture. So there's actually a driving factor here, okay? Epic, stories, terms, rules, all coming down this way. Quality, ERPs, design constraints, interface requirements are all coming down this way, okay? Now, you can see the little B, A, C, D, that corresponds to this other slide. So B, if you recall, is the design. That's platform, and that's domain free, platform independent. Okay, sorry, domain specific, platform independent. So what that means is if I were to look at this model in here, I would know what kind of system it is. I would know if it's a Mars rover or a student registration system, but I would not know what technologies you've chosen. And I can do that model right here. Over here on the architecture side, we have both. We have a PIM and a PSM, but they're separated. So PIM, this is my technology-free architecture, right? And it's domain free. So it's going to be tech free and domain free. I don't know what domain and I don't know what technologies is going on here in A. How wild. Over here, I know the domain, but no technology. Now C, I know the technology, but I don't know the domain still because it's the architecture side. Architects don't worry about the domain specific. They leave that to the designers. And then down here, we join together the technology free model with these technology specific patterns, and we create the platform specific design model from which code should be able to be either auto generated or manually generated. For the most part, there's lots of tools that can auto generate from a PSM, and you can also create tools that can auto generate code from a PSM. Why is this important? Why separate this? This is a really important point here. Change, right? Agilists are supposed to be able to change much more easily than traditional. This supports change. So you look what happens. If you have a new behavioral requirement, a new functional requirement, you would update the analysis model. You would not touch A or C. This is all platform, this is all domain free anyway. So you would update the analysis model, hit the button, and regenerate your design and code just like that. So it's way faster to add new behavior in. Now, let's say we're going to change out our whole database. We need to move to a new database. Okay, cool. The PIM would not change. A database is a database is a database. I don't know what technology you were using when I did the PIM, but the PSM is database specific. And so we would rewrite the PSM and then regenerate the design model. And what that means is, let's say you used that database in 1,000 different parts of your code. All 1,000 parts would be ripped out the old PSM and plug in the new PSM for a brand new design model, then auto-generate your code. So what this means is when technology changes, small amount of change in the model generates huge amounts of design and code automatically. Okay, so that's why you want to separate these things. It's so you can master change. All right, so our final 5 minutes, what I want to do with the final 5 minutes is show you examples of A, B, C, and D items, okay? So I am going to go down to some vocabulary here. Just you can pause on here. This is some of the ways that you can call those A, B, C, D quadrants. All right, so I'm going to come down here for my final 5 minutes, and I'm actually going to go into presentation mode here. All right, so my clock is blocking and my video is blocking the little guy up top. So, okay, here's your example of platform independent architecture. Areas that are high risk. Areas where you haven't decided yet, build, buy, or reuse. You haven't decided, but you still know what it's got to do, right? Even though you don't know what technology, that's perfect for architecture. Describe how to use a given technology to solve a problem, increase significant reuse, et cetera, et cetera. So let me get you to the actual examples here. This is an intro slide. Intro slide. Okay, here's a list of RMA, of platform independent architectural ideas. All these things are important. All these things are difficult, and all these things ultimately you have to pick a technology for. But until you pick that technology, there are still patterns we have to understand while you're picking. And then once you pick the technology, you should be able to swap those in and out if you change your mind down the road. That's the idea of Agile. So by coming up with A, you'll be able to swap technologies more easily. Now, here they're using UML, Unified Model Language. These are classes, class diagram. And what they're doing, though, is they're showing you architectural patterns. Persistence, security, distribution. What you're seeing is no matter what technology you use, you're going to need to be able to create, read, update, and delete. That's guaranteed. Whatever you pick for a tech, got to do these things. For security, you need to be able to authenticate people. You need to be able to decide if they can access a part of the system or can perform a particular activity. That's the pattern. Now, as you pick your implementation tool for this, it's still got to do these 3 things. And the designers can start to design and plug these things in even before technologies have been understood. Okay. Now we're going into C. So that's platform independent. Now in platform specific, you've picked a few of those. Here's 2, persistence and distribution, right? Create, read, update, delete. For distribution, it's get remote reference, right? There's an object on another computer that you need to be able to, call the methods on. Well, you need a reference to it. Once you have the reference, the underlying technologies can make the signals go across whatever technologies you've picked. But in the end, you're calling a method on some remote object, okay? So here you can see that there's design patterns and implementation patterns. So let's start far right, implementation pattern. For persistence, we're going to use JDBC for all legacy data, but we're going to use object store for all new data. That's the example here, right? So you have RDBMS would be the design pattern here, and OODBMS would be the design pattern here. I can write these designs. As long as I pick another relational database, these designs are going to be largely untouched. If I pick another object-oriented database, these are going to be largely the same as well. So even these design patterns tend to be a little more stable, but they are still physical. They are still tied to a specific idea, a specific technology. Down here for distribution, they've decided to use Java 1.2 from Sun. That design technique is called remote method invocation. Again, you could use a different RMI tool, and a lot of this might stay the same, okay? So in the end, what's happening here? They've taken their architectural patterns and they have decided on real technologies, and they must show us how to use those technologies to achieve those goals. So how do you create, how do you read with JDBC? How do you get a remote reference with Java 1.2 from Sun? Those operations you saw on the classes, We now have to design out sequence and class sequence diagrams, right? How do you use these things now that we know the technology? Now we're in C, okay? This is also UML. What these red things are placeholders. These are amazing. Again, if you can auto-generate these, if you bind real classes to these, it'll generate the entire model underneath it. So here you can see they're binding real classes for a schedule, for a registration system. This is for a course registration system, right? They have parameters. They have these here, technology-specific classes. This is all part of the pattern. And you can even have sequence diagrams that show, look, here's the technology-specific stuff that you get from JDBC. Was it JDBC? From JDBC. And then here are the ones that you got to create yourself. DB persistent class is one of the ones you have to supply. So it actually shows you what you got to supply. And if you know how to read sequence diagrams, you can code from them. Here are some class diagrams, and you can see this is the pattern, and they can actually replace these items with the actual classes they need. Very little coding is needed. So that's examples of A and C. Boundary entity control pattern or boundary control entity pattern, however you like it. What's that an example of? A, can't tell the technology or the domain, right? Here's a sequence diagram that shows how to do that. Again, I don't have time to go through all these, but that's an example of design because I can actually see that there's an employee, a time card manager, so I can see this is a time card application. So that's pretty much it. There's a lot more I could show you in this, but in the end, the architects are creating patterns that are technology free, and then later that are technology specific. And they are, and the designers are creating domain specific technology free designs. And then later they bind to technology specific ones by ripping out classes and filling in their own. So that's a little longer than 15 minutes, but hopefully you got some gems in the back of your head as to what you might do to separate architecture from design. Thank you very much. My name is Anthony Crane, and I hope that you enjoyed this